Hello and welcome back. In this video, we will be discussing two-way tables. Two-way tables summarize counts for two categorical variables. Each observation belongs to exactly one category from each variable. Okay, let's review some vocabulary. Categorical variable places observations into groups or categories. I want to make a note here. I'll keep this in. This type of data is considered qualitative. I usually need to sound that word out whenever I spell it. This is the kind of jargon or language you're going to be hearing often in a statistics course. Qualitative data refers to categorical data, whereas quantitative data refers to numerical data. Okay. All right. Next, joint frequency, the count in an interior cell. Marginal frequency, totals along the margins. So the totals for a row or a column. And remember, rows run left, right, columns run up, down. Conditional relative frequency, percent within a row or column. And association, when the distribution of one variable differs depending on the other variable. In this video, we're mostly going to be focusing on the joint frequency, marginal frequency, and conditional relative frequency of two-way tables. All right, let's take a look at an example here. So here we have a two-way table, 100 students surveyed, male and female, on whether they play sports or perform music. So I tried to color code it so we could see what lines up with what. I hope that doesn't make it more confusing. But if we go left to right here, we start with male. 30 males play sports, 20 males perform music. 30 plus 20 gives us our 50 here in this total column. That's why I tried to align blue with blue. Likewise for the row. Oh, this column, this row. Yeah. For the female row, we have 20 females who play sports, 30 females who perform music for this 50 right here. And then going up down for sports, 30 males who play sports, 20 females who play sports, 50 students play sports. Music, 20 males perform music, 30 females perform music for a total of 50 students in total performing music. And then whenever you create your two-way table to check that everything is, more often than not, your work is good, is if this bottom total column adds up to this number, and also this total this one's a row, this one's a column. Geez, keep mixing up my words. This total row adds up to the same thing as this total column. 50 plus 50 is 100. 50 plus 50 is 100. If the sum of these does not equal the sum of these, there's a mistake somewhere that needs to be fixed. This sum should always equal this sum. Okay. All right. So I have all three here. We have the calculations for all three of them. They're very simple calculations. Joint relative frequency is the observed cell. I should make a note of that instead of just cell. Let's call it observed cell. There we go. Joint relative frequency is the observed cell divided by the grand total. So males and sports, okay. So male and sports, you can see here we have 30 males who play sports, 30 up here. And then we divide that by the grand total. In our example, the grand total is 100. So the males who play sports is 30 divided by 100, which comes out to 0.3, or we can call that 30%. Okay. Marginal relative frequency. This is given as the row or column total divided by the grand total. So an example of this is just what is the marginal relative frequency for males? Okay. So males, we look at the total is 50. And the total number of students being surveyed is 100. So our marginal relative frequency will be 50 males divided by 100 students, 0.5 or 50%. And lastly, conditional relative frequency. This is I'm going to write that again. Let's change that. I don't like how I just wrote cell. This should say observed cell. Okay. So this is our observed cell divided by the row or column total. Now, the notation you're going to see for these types of questions might look a little weird. This might not be something you've seen before. So I'm just going to let you know this is read as P of sports given male, or more formally, the probability of playing sports given the student is male. This vertical line here means given. Okay. So anyway, we calculate this first one. P of sports given male. Okay. So the first thing we look at is sports male, 30. And then we divide that by the whatever is after the given, which is male, and that's 50. 50. So probability of playing sports given your male is the amount of male sports players divided by the total number of males. 30 divided by 50. 0.6 or 60%. And just another example to drive it home. This table's not too big, but it doesn't hurt. Probability of a student performing music given they are male. Okay. We have 20 male students who perform music. There are 50 male students in total. It's 20 divided by 50. 20 divided by 50, 0.4 or 40%. And a good way to quickly check this, I didn't write it out here, I didn't really feel the need to, but whenever you analyze the same given row or the same given column, it should all add up. So our only columns are sports and music, and we're observing the male row. So this should add to 100 because these are our only two options for what a male could do, sports or music, for this example, okay? All right, some common mistakes. Using the wrong denominator for conditional probabilities. Be careful, we're using the correct thing for what we're doing. If you notice, all of the examples, the denominator is always the total. And something that might help you remember is the only one that is just the row or column total is the conditional relative frequency. And again, whatever the given is, that's the row or column total we're looking for. For joint relative frequency and marginal relative frequency, the denominator is always the grand total. Confusing joint and marginal frequency. Okay. So joint and marginal both have grand total as the denominator. What might help you remember separating the two is, I don't know if this is the best way to remember, but it works for me. When you go to jail, you're in the joint. When you're in jail, you're in a cell. Joint and observe cell. Just think of like, okay, jail, joint, cell, cell. These kind of go together. And then marginal relative frequency simply is just the other one. Forgetting to convert counts into proportions, decimal, or percentages. So statistics is the only course you will ever hear me say this. In statistics, we always want our answers in decimals or percentages. Any other math class, every other math class ever, fractions are far superior, but when we're dealing with stats, we want it in decimals or percentages because typically we're talking about percentage of information. And like saying, I can't think of a complicated example in my head because we know like what 1 out of 20, you could say 1 out of 25 students, are taller than 6 feet. But you could also say 4% of students are taller than 6 feet. They convey the same message, but sometimes it's not as obvious when talking about fractions. Either way, just remember we want decimals or percentages. And then you're gonna hear me say this a lot throughout this unit. Another mistake, claiming causation from an observed association. There's a famous saying in statistics, correlation does not imply causation. This I will go into in more detail in later videos. Just remember, correlation does not imply causation. All right. Here we have a practice problem. Let's take a look. There's a lot on the page here. Let's cover up the solutions. All right, can we see the whole problem? Yeah, we can see the whole thing. Okay. So, use the following survey of 120 students to answer the following questions. We have this table here. I'm not going to read the whole thing. 1, find all joint relative frequencies. 2, find all marginal relative frequencies. 3, calculate probability that a student plays sports given they are male. 4, calculate probability that a student plays sports given they are female. And lastly, compare the conditional distributions and determine whether there's appears to be an association between gender and playing sports. Question 5 I like being thrown in here because it kind of encompasses why are we even talking about this information. We're looking to see like what can we confer, I think is the word, from the given data. Anywho, feel free to pause here and take a stab at these questions. All right. Hopefully we worked on these. Let's take a look at the answer. So number 1, before I even go down to the answer, find all joint relative frequencies. So remember, joint and marginal, we're always dividing by the total, whereas what's that one called? Conditional, thank you. Conditional, we just focus on the row or column. So we can take a look at these really quickly and see that for the first one, the first joint relative frequency is males who play sports, which is 38 divided by 100. Males who don't play sports, 22 divided by 120. Sorry, I should have said 120 for here. Females who play sports, 27 divided by 120. And females who don't play sports, 33 divided by 120. And you can see I have all that right here. And I even note they all add up to 100. So males and play sports, 38 divided by 120 gives us these numbers here. Now, let's look here really quick. I write males and sports, and then like kind of raised to the power C kind of thing. This symbol here means complement. It's a shorthand way of saying not. We use this very often for statistics. I'm definitely going to use this notation again in the future. Just kind of want to introduce it here. But this reads male and does not play sports, which is, like I said before, 22 over 120. Female and play sports, 27 over 120 gives us these values here, and female and does not play sports, 33 over 120 gives us these values here. All right. Cool. So now we find all marginal relative frequencies. Okay. So yeah, that's just, so the marginal, and like, so another thing that helps me remember marginal is, so let's put in a highlighter here, just ways to help remember what these words mean. Everything I have highlighted here, those are called the margins. Okay, that's literally the name for those. So the marginal relative frequency is looking at the totals for that. Okay, so let's get rid of those. So we're going to look for total, the marginal relative frequency of all males, the marginal relative frequency of all females, marginal relative frequency for all students who play sports, and marginal relative frequency for all students who don't play sports, which I have all of that here. Yep. Male, there's 60 males, 120 students in total, 50%. 60 females, 120 students total, 50% for that. And these both add up to 100. And then total students who play sports, 65 out of 120, about 54%. And total number of students who don't play sports, 55 out of 120, roughly 46%. Okay. All right. Next one. Probability a student plays sports given they are male. Okay, so the given is male. So we're focusing now all right in here. 38 males play sports out of 60 males in total. So we should have 38 over 60. Yep, right there. 38 over 60, roughly 63%. Likewise, now we're looking at, what is it, females who play sports. Okay, so now we're focusing here. 27 females play sports out of 60 females in total. That's going to be 27 over 60. Yep, 27 over 60 we have right over here. So for the last question, compare the conditional distribution, determine whether there appears to be an association between gender and playing sports. Okay, so I took a look. So here we already did probability sports given male and probability sports given female. So then I looked at not sports given male and the probability of not sports given female. And we could see that clearly, if we look at the males who play sports and the females who play sports, we have more, about 1.5 times the amount of males playing sports as opposed to females giving sports. So we could say that There appears to be an association between gender and playing sports because the conditional distributions are so different. About 63% of males play sports, while 45% of females play sports. Likewise, the percentage of males who don't play sports is way lower than the percentage of females who don't play sports. So we could confer that males are more likely to play sports based on the given data. If there was no association, we would expect these conditional distributions to be approximately the same. If it was all 50-50-50-50, then we can just confer like that gender has no effect on whether or not a student plays sports because it's 50-50 for everybody. Okay, cool. And that's everything I have for you on two-way tables. Thank you for tuning in. As always, a link to the notes will be in the video description. And I will see y'all next time. Take care.